Greetings for the day. Welcome to another session of Multimedia Technologies. My name is Mohammed Rahmatli. In today's session, we're going to learn about the Chroma Subsampling. In the last session, we started with this particular topic and we had stopped with just the introduction. But in today's session, we're going to learn in detail about the Chroma Subsampling. So in the last session, we studied about the analog and digital video, and also we have seen the differences between them and how it is different from one another. Now in today's session we are going to continue the part and we're going to study what do you mean by chroma subsampling. Now what is the purpose of this chroma subsampling? This chroma subsampling is used to indicate the color differentiation, as human eyes doesn't have the tendency of differentiating the colors, and it has a wide spectrum of seeing white and black color when compared to other colors, and recognizing all of this color. Human has a good eyesight in recognition of black and white color, like the shades between white and black color, all of the shade like gray, dark gray, and all of things, complete white or complete black. So we'll be sampling the things in such a way that it's like it regulates or it simulates in such a way that we will be able to differentiate the color. Okay, now we're going to see how these things happens and what are the different methods, and also we are going to see about the aspect ratio in the last of the session. Now what it says over here, since humans see color with much less spatial resolution than they see black and white, it makes sense to decimate the chrominance signal. Now just to make you understand what this particular thing is, if at all if you have been to any of the picture, if at all if you start zooming that particular picture to its maximum extent, if at all if you have taken a picture and you are zooming in that into that particular picture and to the maximum limit, if at all if you have zoomed it, then you will see a small square boxes. Around it you will see some white or black color. Around that particular boxes or that particular picture zoom, you will see some of the white or black color surrounded by some of the boxes. That particular thing, how it is been distributed and how it is been done, is been said in this particular chroma subsampling. Now what it says, interesting but not necessarily informative, names have arisen to label the different schemes used. Okay, now to begin with, the number are given stating how many pixel values per 4 original pixels are actually sent. Now this is the general sample that has been sent, which is 4:4:4. What it says, the chroma subsampling scheme 4:4:4 indicates that no chroma subsampling is used. Each pixel's Y, CB and CR value are transmitted 4 for each of Y, CB and CR. Now what is this? This indicates the value of sample taken and the number of samples been taken into consideration, and number of rows and number of values that is been taken into consideration. It indicates 4:4:4 value. Now further it says the scheme 4:2:2 indicates the horizontal subsampling of CB CR signals by a factor of 2, that is of 4 pixel horizontally labeled as 0 to 4, 0 to 3, not 4, sorry. All 4 Ys are sent and every 2 CBs and 2 CRs are sent as CB0 Y0, CR0 Y1, CB2 Y2, CR2 Y3, CB4 Y4, and so on averaging is used. Like this is how the sampling will be done. Now for what purpose we will be using sampling? This sampling has been done to regulate the color samples. The main agenda or the main theme of this particular subsampling is to make that particular sample of color to be similar. For an example, if at all, like see, we are not talking about the HD quality of images, or we are not talking about the HD super HD, or what you call as the 4K type of videos. We are talking about a normal picture. If at all we are zooming in that particular picture, you to the maximum extent when it is been zoomed, you will be able to see some of the sample colors. Around that you will be seeing some of the white and black colors. Actually those are not white and black color, those are the sampled colors. If at all, if you zoom out of the things, you will not see white or black color around it. But when you zoom in into that particular picture, you will be able to see some of the white or black outlines on that particular picture, if at all, if you observe it very keenly. Now for this particular thing, a sampling value will be done, and according to that sample the color value will be chosen. Okay, now the same thing is been said in the point C. It says the scheme 4:1:1 subsample horizontally by a factor of 4. Now and 1 sample has been taken into consideration. The scheme 4:2:0 subsamples in both the horizontal and vertical dimensions by a factor of 2. Theoretically, an average chroma pixel is positioned between the rows and columns as shown in figure 5.6, which is in the next slide. Now scheme of 4:2:0 along with other schemes is commonly used in JPEG and MPEG type of things. Now this is the chroma subsampling pictures. If at all we observe the white color things, it is a pixel with only Y values, and if at all if you observe all of the black one, it is the pixel with only CR and CB values. Whereas if at all if you see a black surrounded by white outlayer, it is the pixel of Y, CR and CB values. This is how the things is been done. If at all if you observe it over here, here it is 4:4:4, here is 4:2:2, here is 4:1:1, here it is 4:2:0. If at all if you see, all of the samples are been covered in this. Here 2 samples are taken into consideration. Here 1 sample is taken into consideration. Here no sample is taken into consideration. So this is a major difference. Just for an idea, I have told you all of these things. Okay. Now the next one is with reference to CCIR standards for digital video. Now what is this CCIR? CCIR is the Consultative Committee for International Radio, and one of the most important standard it has produced is CCIR 601 for component digital video. Now what is this? This standard has since become the standard ITU-RE-601, an international standard for professional video application. Okay, now adopted by certain digital video formats including the popular digital video or DV video. Okay, now which also says, like, the next table figure 5.3 shows some of the digital video specification with all the aspect ratio of 4:3. The CCIR standard 601 standard uses an interlaced scan, so each field has only half as much vertical resolution, example 240 lines in NTSC. Okay, now what is this? CIF stands for Common Intermediate Format specified by CCITT, which is International Telegraph and Telephone Consultative Committee. The idea of CIF is to specify a format for low bit rate. Now what do you mean by this low bit rate? Just to make you what do you call as understand what actually happens it over here. Now considering you are recording a video, okay, considering you are recording a video by your mobile phone. If at all if you record a video for approximately about 30 minutes or 40 minutes, then the file size of that particular video will be approximately about 2 GB or 3 GB. But when you see any of the HD movie or any of the HD or 1080 movie, you will see that movie will be maximum of 1 GB or 1.2 GB, whereas your video which you have recorded only for 30 minutes or 20 minutes, it is crossing 2 GB of size. How it is possible? Like, what is the difference between all of these two things? The main difference here will be the bit rate. The bit rate is a major difference between all of these two videos. The bit rate will be very low when compared to your normal camera by which you are recording. The bit rate will be less, whereas the bit rate will be high in your mobile particular phone, whereas the bit rate will be low in the movies. Okay, now the next one, it says CIF is about the same as VHS quality. It uses a progressive non-interlaced scan. Further it says QCIF stand for quarter CIF. All the CIF QCIF resolutions are evenly divided by 8 and all except 88 are divisible by 16. This provides a convenience for block based video coding in H2.61 and H2.63. Okay. Now next one, it says, note, CIF is compromise of NTSC and PAL in that it adopts the NTSC frame rate and half of the number of active lines in as in PAL. Like, see, we have different types of videos, S videos, NTSC and PAL type of videos. There are different types of video that has been taken into consideration. Now the below is a table which represents the digital video specification. Like, you can just pause the video at this instance and you can see the different or the difference in the different resolutions and the aspect ratio and the color subsampling with reference to different format, with reference to CCIR 601, CCIR 601, which is another one like 625 by 50. The first one is with reference to 525 by 60. The next one is with reference to CIF, and the next one is with reference to QCIF. So these are the different what you call as specifications with reference to different format. Okay. Now the next one is with reference to the HDTV, which is high definition TV. Now what do you mean by this, and why this particular thing has been introduced in the what you call as in the TV industry? What was the purpose and why it has been introduced in the video industry? What was the reason? See, the main reason is to provide the picture quality of the video and for the user experience and for a greater clarity of the picture. Okay. Now for this particular thing, if at all if you observe, when you record a video and when you upload a video at any of the platform, the pixel size will get reduced, whether it is with reference to YouTube, whether it is with reference to any of the video streaming platform, also with reference to the photo that you have taken, and when you upload that particular photo on any of the messaging app, you will see there will be a difference in the pixel size and the picture will get somewhat blur, or the pixel size or the quality of the image will be reduced. So to compare with all of these things, this particular concept of high definition TV was introduced just to improve the user experience. So what it says over here, the main thrust of HD TV or high definition TV is not to increase the definition in each unit area, but rather to increase the visual field, especially in its width. If at all you see in HD video, the video will be in a longer format in terms of width. If at all if you see with reference to the what you call as QTV or LED TV, LCD TV, these TVs are wider, they are not in greater in height, but they have a longer width. Also to increase the user experience, the curved TV is also been introduced to increase the visual experience. And on this curved TV, many of the people play the 3D games or any of the gaming streaming platform is been done so to get more of the experience. Now the next one, it says the first generation of HDTV was based on an analog technology developed by Sony and NHK in Japan in late 1970s. MUSE, which is multiple subsampling encoding, was an improved NHK HD TV with hybrid analog digital technologies that was put in use in 1990s. It has 1125 like 1125 scan lines, interlaced 60 fields per second and 16:9 aspect ratio. Now what is this? This is with reference to the improvement in the width of the TV, improvement in the experience of the watching any of the picture or video on the screen. If at all if you observe, like in the smart TVs or at all in HD TVs, the only thing that you feel difference is the experience that you get and the clarity that you get, okay, in that particular picture. If you play a particular video in your mobile phone and the same video you play it on any of the TV, smart TV, you will feel the major difference between these two things. What was the major difference? The first difference will be the width in size, and the second difference will be in the experience that you get from there. Okay, the same is with reference to the sound quality. Like if at all if you see any of the sound quality with reference to the 320 value And also if at all if you see with reference to 128 bit, 320 bit, then you will feel the difference in the sound quality. The sound quality will be different, and you can listen to the background music, whereas you cannot see, we cannot listen to the background music in 128 bit of the sound. The same applies over here. It is all with reference to the user experience that you are taking from the particular scenery. Now the next one is with reference to, since uncompressed HDTV will easily demand more than 20 megahertz bandwidth, which will not fit the current 6 megahertz or 8 megahertz channel. Various compression techniques are being investigated. It is also anticipated that high quality HDTV signal will be transmitted using more than one channel even after the compression. Now, this is a brief history with reference to the HDTV evolution. I'll just read it for you, or else you can pause at this particular span of time and you can read all of the things. I'll just read it for you. A brief history of HDTV evolution, which is in 1987 the FCC decided that HDTV standard must be compatible with the existing NTSC standard and to be confined to the existing VHF, which is very high frequency, and UHF, which is ultra high frequency bands. Now further, in 1990 the FCC announced a very different initiative, that is its preference for a full resolution HDTV, and it was decided that HDTV would be simultaneously broadcasted with the existing NTSC TV and eventually replace it. This is the reason why you will be having Star Sports 1, Star Sports 2, Star Sports HD, Star Sports 1 HD. This is the thing which is been said over here. With reference to the normal channel, this also will be broadcasted, and you will be taking a special type of package for accessing this particular channels. Now third point it says is, witnessing a boom of proposal for digital HDTV, the FCC made a key decision to go all digital in 1993. A grand alliance was formed that include four main purposes by General Instruments, MIT, ZIT and AT&T, and by Thomson, Philips, Seranoff and others. This eventually led to the formation of the ATSC, which is Advanced Television System Committee, responsible for the standard for TV broadcasting of HDTV. Further, in 1995, the US FCC Advisory Committee on Advanced Television Services recommended that the ATSC digital television standard to be adopted. Okay, now this was just a brief history with reference to the HDTV and evolution. Further, the standard supports the video scanning format shown in the table 5.4. In the table, I means interlaced and P means interlaced scan, and P means by progressive non-interlaced scan. Like in the further, like for figure 5.4 indicates the advanced digital TV format supported by ATSC, which has 1920 by 1080, which is 1080p type of standard HDTV. Below is the picture rate with reference and aspect ratio with reference to the different active pixel lines and active lines with reference to aspect ratio and the picture rate. So this is the table which defines the different ratios and aspect. Now further, for video MPEG2 is chosen as the compression standard. For audio, AC3 is the standard. It supports the so-called 5.1 channel doubly sounded like sound, that is 5 surround channels plus a subwoofer channel. Okay, now the next one is with reference to the salient difference between the conventional TV and HDTV is the HDTV has much wider aspect ratio of 16:9 instead of 4:3. So that's the reason we have a greater picture, and this picture need to be encrypted and decrypted, like not encrypted and encrypted actually, it is to be encoded and decoded actually. Encoded and decoded with reference to the screen size, and also with reference to, if at all if I tell you in this way also, when you change your monitor of your PC, at that instance the resolution that is been taken will be a different one. If at all if you click on auto the bottom of the screen, then the screen will automatically get adjusted. If at all if you adjust it manually, the screen size will get different. If at all if you click on auto, the screen size will automatically be chosen by the system. Okay, this is how which is been said over here. It is only with reference to the aspect ratio of the screen. It is totally with reference to the aspect ratio of that particular screen and manually what you are setting. In some of the channels, like see, if at all if you observe this particular screen, if at all if you observe this particular screen, see, here is some of the place is black and here some of the space is black. This is not been utilized. If at all this would have been in an HDTV, this would also have been reused. Like, you know, this also was to be used with reference to the HDTV. Why? Because the aspect ratio of this particular screen is different, whereas with reference to the screen, the size is very much less. Okay. Now, the second difference is like HDTV moves towards progressive non-interlace scan. The rationale is that interlacing introduces serrated edges to moving objects and flicker along horizontal edges. Okay. Now, with reference to the aspect ratio, like I have told you, with reference to aspect ratio, what are the problems with reference to the aspect ratio? What if the display AR is less than the production AR? This is how it happens. Like, see, if at all if you see this part of the screen, is very much clear, whereas if at all if you see towards this particular part, this is getting blur. This part is getting blur. So this is one of the problem with respect to the aspect ratio. Also, we are going to see the different problems with reference to the aspect ratio. This is the first problem that we have seen. If at all if you like see, if at all the aspect ratio is less, and if at all if you want to project it on a larger screen, then this is how, or this is what it happens, like the pixel size will get stretched and it will get distorted. Now the next one is with reference to the letterboxing. What it does is, like, you know, like my screen is there, like see, here is black, here is black. That is been done over here, simply shrinking vertical to the fit. This is how it is been done with reference to the letterboxing. Though the screen size is this much, only this particular size is being utilized to project the video or sample the video. Next one is with reference to the cropping. Next one is with reference to the cropping. If at all if you observe this particular image and this particular image, this particular part is being removed in the next picture. Just cutting it to fit the screen. What is the screen size which is there? It will cut down into that particular screen size. So this is with the reference to the cropping of the video. This also will happen. Okay. Now the next one is with the, like, this is a general example. This is a wide screen and this is a normal screen. This is a particular complete screen with reference to in the wide screen, and this is with reference to the normal screen. Only this part is being projected. Only this part of screen is being projected, and whereas with reference to the wide screen, this is the major thing which is being covered. So this is one of the, this is another problem with reference to the aspect ratio. Then the next and the last one is with reference to the pan and scan. It says if there will be a lot bigger picture, but you will be focusing only on that particular part. If at all if you want to understand this particular thing, you can better understand this particular thing with reference to the 3D camera. If at all if you are viewing any of the video with reference to the 3D camera, you can move the video accordingly. You can see 360 degree of that particular area. Just you need to scroll that video, and it will show you the 360 degree of the value. That is what we call as pan and scan with reference to the window screen. Okay, this was all for today. I hope you understood something from today's session. If at all if you have any doubt with reference to today's session, please ping me at rahmat_ali2u@theideout.com, or we can have a doubt clarification session soon in the coming classes. Thank you for listening. See you in the next session.